With paper 1 out the way, it's time to turn our attention to paper 2. So today's video covers my top 4 tips for GCSE Maths paper 2 revision. Tip 1, my paper 2 revision checklist. Using the link in the description, go to my website and download my paper 2 revision checklist to identify the topics that you need to prioritise. Then work through those specific video lessons available for free on my YouTube channel. Tip 2, my paper 2 practice booklets. Once you've worked through the YouTube lessons identified by the revision checklist, then you need to work through my paper 2 specific practice booklet to solidify your understanding of the topics in preparation for the exam. Tip 3, my paper 2 practice papers. The night before the exam, it's time to complete my paper 2 practice paper to refresh your understanding of the topics that I'm guesstimating will appear on paper 2. Tip 4, my rapid revision system. Alternatively, if paper 1 didn't go as well as you were hoping, or you just need a time-efficient solution due to the other subjects that you need to revise for, then you should sign up for my rapid revision program upgrade, as it combines all the benefits of the previous points but turns them into a personalised revision plan for paper 2, which means that all you need to do is complete my paper 2 revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but if you sign up for 1 month now, then you'll get priority access to both my paper 2 and 3 specific revision resources. Sign up for a free trial of Upgrade today. Okay, welcome to this video where we'll be having a look at a practice paper for the 2025 Paper 2 Foundation Tier exam. As always, there will be a QR code on the front of this booklet so you can get back to this video at any point. So we'll get started with the questions. We've got question 1, which is write the number 32,078 in figures. So that is 32,078. The next question is to simplify 3t times 4w. 3 times 4 is 12, and then we just list t and w along with that. 0.78 as a percentage is a nice one, it's just 78%. Question 4 is to draw a radius of the circle. So to draw a radius of the circle, we go from the centre to a point on the circumference with a nice straight line. Doesn't matter where on the circumference, we do this with a ruler. And there we go, that would be a radius of this circle. For question 5, we have listing or a listed set of numbers and it asks us to find the median. So the median is the number in the middle, as long as the numbers are in size order, which these are. To find the median, we can either cross off or underline the numbers from each side, one from the left, one from the right, until we get to the middle. And here we go, we have 75 in the middle, so our median is 75. Question 6 here says write down a suitable metric unit for measuring the height of a tree. So a suitable metric unit here would be metres. So there we go, we would have metres as our suitable metric unit. Question 7 is about coordinates. So we have write down the coordinates of point A. Point A there has an x coordinate of 6 and it has a y coordinate of -2. So there we go, that's the coordinates of A. Question B is saying on the grid, plot the point with coordinates -2, 7 and label it B. So -2 is down here on the x-axis and we want to go up to 7. So here we go, our point would be just there and we would label that point B and there we go, there are our coordinates. And there we go, that was the end of the question. Question 8 says Amina is going to have a meal. She can choose 1 starter and 1 main course from the menu. And we have the menu here with 3 starters and 3 main courses. It says write down all the possible combinations that Amina can choose. Now, as long as these all have different letters, we can shorten the language here. We don't have to write salad pasta. We can write salad with pasta, salad with rice, and salad with a burger. We can then move on to the fish. So we'll replicate these 3 combinations but with the fish. So fish with pasta, fish with rice, and fish with a burger. We then have the melon as the last one there. So we've got 3 more to do: melon and pasta, melon and rice, melon and burger. And just take note of the logical way that we went about that. We picked the first starter, matched it with all the other mains, and then just followed that logical process moving through them. And there we go, that was some listing combinations. Question 9 here, we have Liam wants to book a holiday. The holiday will cost £1,428 and Liam will pay a deposit of £150. He'll then pay the rest of the cost in 6 equal monthly payments. How much is each monthly payment? So the deposit is the bit that he pays at the start. So before we figure out how much he'll pay per month, we need to take away the deposit. Again, we are using a calculator, so we'll just type that in, 1428, take away 150, and that is equal to 1,278. As he's going to pay this over 6 equal monthly payments, we'll divide that by 6, which will split that into 6 equal parts, and that comes out as 213. So that's in pounds, so we'll check the dotted line, it's got the pound sign on, so 213. And there we go, there's our final answer, looking at this concept of paying a deposit and then splitting the rest into monthly payments. Our next question is a picture sequence. So it says here are some patterns made with dots. In the space below, draw pattern number 4. So if we have a look, going from pattern 1 to pattern 2, what's been added on? Well, we have this extra 2 dots at the top and we have an extra 2 dots at the bottom. So every pattern is adding an additional 4 dots. So if we're going to draw this next pattern, first we want to replicate pattern number 3 as best we can. So we have the 3 dots in the middle. Now we have 2 there, 2 down here, 2 up there, and 2 more down here. So we're going to add on an additional 4 dots. So if I do those in a different colour so you can see which ones I've added on. So an extra 2 there, and an extra 2 here. And there we go, there is pattern number 4. For part B, it says how many dots are needed for pattern number 8. Well, if we turn the picture sequence here into a number sequence, we can figure it out using numbers. So pattern number 1 had 3 dots, and then an extra 4 was added on. Of course, we could use our calculator to just keep adding 4, so it's not too bad if we use a calculator either, but adding 4 gets us to 7, add 4 again gets us to 11, then 15, which is the one we just drew, and we want to go an additional 4 more down this pattern. So 19, 23, 27, and 31. Now, of course, you have a calculator, so you could just keep adding 4. You don't need to sort of worry about making a mistake there along the way, even though you are just adding 4. Just double check on your calculator, and we get 31 as our final answer. Question 11, it says there are 19.5 litres of water in a water container. A cup holds 210 millilitres of water. How many cups can be completely filled using the water in the container? So of course, straight away, we can see here that we have different units. So there are 1,000 millilitres in 1 litre. So we can convert that into millilitres by multiplying it by 1,000. So on my calculator, 19.5 times 1,000 is equal to 19,500 millilitres. It says each cup holds 210, but we want to know how many can be completely filled. So not partially filled, but completely filled. So if we divide our total by the 210 that goes into each cup, we'll get an answer. That answer comes out as 92.857142. We've got some recurring dots above the 8 and the 2 there, and now we can figure out how many can be completely filled. So what we found here is that 93 cannot be completely filled, but 92 can be completely filled. So in this case, we're rounding that number down as it's asked for how many can be completely filled. We can fill 92 and almost get to 93, but only completely fill 92 cups. So there we go, our final answer would be 92. Okay, question 12. We have a conversion graph, and it says this graph can be used to convert between stones and kilograms. So here it says change 3 stone into kilograms for part A. So we would go up from 3 stone using a ruler and a pencil, and then really carefully going across, and then really carefully reading the scale and making sure that we get this perfect. So in the middle there is 15. So every square going up is equal to 1. So that is going to be 19 kilograms. So there we go, our final answer for part A is 19 kilograms. For part B, it says to change 80 kilograms to stone. The problem here, our graph doesn't go up to 80. So we're going to have to find a number along the side here which can turn into 80 nicely. So we could go for 10, 20 or 40. I quite like just going for 40 here because I just have to times my answer by 2. And if I go down, it does look like that goes through part of a square, which is a little bit awkward, but should be absolutely fine. Let's have a look. So it's halfway between that square. Double check the scale. So that's 6, here's 7. So that's 6.2, 6.4, 6.6, 6.8. It's part way between, for me, between 6.2 and 6.4. So let's say that's 6.3 stone. So if I want to get to 80 kilograms, well, 40 kilograms is equal to 6.3 stone. And to get to 80 kilograms, I need to multiply that by 2. So 80 kilograms is going to be equal to 12.6 stone. And there we go, that would be my answer, 12.6. And there we go, there's using a conversion graph where we've had to scale up one of the answers as well. Question 13, we're looking at some algebra, so we have work out the value of d when p is equal to 2. And it tells us that d is equal to 3 lots of p plus 4. So remembering, 3p means 3 times p, so we have 3 times 2, and then add 4. 3 times 2 is 6, add 4 is equal to 10. So d is equal to 10. For part B, it says make p the subject. We have the same formula there. So for making p the subject, we want it to say p equals or equals p. To make it say that, we have to get rid of this 3 and we have to get rid of this plus 4. So the first thing we'll do is take away the 4 and we get d minus 4 is equal to 3p. We can then divide by 3 and we'll have equals p, which has made it the subject. On the left, we just need to write that as a fraction. So d minus 4 all divided by 3. Now you can swap that round so we can have p equals and then put the d minus 4 over 3. Or you can leave it as equals p. Either way would be absolutely fine. But there we go, that is making p the subject. For question 14, it says on Saturday, a bookstore sold a total of 250 books. 72% of the books sold were fiction books. The rest of the books sold were non-fiction books. How many non-fiction books did the bookstore sell on Saturday? Now, there's 2 ways we could approach this. We could work out the 72% that were fiction books and take it away from the total, or we could work out the percentage that are non-fiction and then just work that percentage out. Completely up to you. It's the same amount of work either way, but we can do 100 take away 72, which leaves us with 28%, and then just work out 28%. Now, there are a couple of ways to work out 28%. Probably the easiest way is we could just do it using the concept of 100% being 250, and then just go down to 1%, and then turn that into 28%. And that is dividing by 100, and then timesing by 28. You can also use a decimal here. You could multiply by 0.28. It just depends which way you prefer working out percentages. Either way, absolutely fine. So 250 divided by 100 gives us 2.5. That's 1%. Times that by 28, and we get the answer 70. So 70 of the books were non-fiction books. Now, if we'd have worked out the 72%, we can do 250. I'll use a decimal method times 0.72. That gives us 180. And then 250 take away 180 would give us 70. Either way, absolutely fine. But our answer there is 70. Question 15 is looking at a frequency tree. So for this frequency tree, it's given us some information. It tells us 60 people are asked if they prefer to text or to email their friends. That's shown in the frequency tree. 38 of the people are women and the rest are men. So 38 in this box, and we can do 60 minus 38, which gives us 22 men. It then tells us 15 of the men prefer to email their friends. So for the men, we have 15 in the email circle, and then we are looking for how many prefer to text. So we can do 22 minus 15, and that gives us 7. We can write our working out down at the side, 22 minus 15, and there's 7. And then it tells us 36 of the people prefer to text their friends. So if 36 prefer to text, well, it doesn't tell us anything about the women, but it does now link together these two text areas, which tells us that the total is equal to 36. So if 7 of the men prefer to text, well, then this one here would be 36 take away 7, and 36 take away 7 is equal to 29. So that would be 29, and then the final box here is the 29 taken away from the 38. So 38 minus 29, we can do that on the calculator just to make sure we don't make any mistakes, and that's equal to 9. And there we go, that's our completed frequency tree. Now this also asks us a question. It says one of the people is picked at random, find the probability that this person is a female who prefers to text. Well, out of all of these, the females that prefer to text, we have 29 of them. Now it says one of the people, or one of these people, is picked at random. So if we're picking from one of the people, then it's out of 60. It's not specified here that one of the men is picked or one of the women is picked. It says that one of the people is picked. So that's going to be 29 out of the original 60. And that'd be our final percentage there, 29 out of 60. Now you don't need to convert that into another form, it's fine to leave it as a fraction, and you don't need to simplify it if it does simplify. So the best way, just leave it as a fraction there, don't overcomplicate it, potentially make a mistake trying to simplify it or convert it into a percentage or something along those lines. And there we go, there is our frequency tree with a probability question alongside it. Question 16 is looking at the area of a trapezium. So you have the formula for the area of a trapezium, area is equal to half a plus b h. Now A and B are the two parallel sides in either order, and h is the height or the distance between them. So to work out the area of a trapezium, we take those two parallel sides, 10 add 16, we then halve it or divide it by 2 and then times it by the height, which is 7. Now thankfully all of that can actually be typed in one go in your calculator. So 10 plus 16 divided by 2 is equal to 13, and times that by 7 is 91. So the area of this trapezium is 91 centimetres squared. And there we go, that's some area of a trapezium. Question 17 here asks us to reflect shape P in the line y equals 3. So the y-axis is this one going up and down, and this is where y is equal to 3. So the reflection line for y equals 3 is a nice straight line going through y equals 3. And we just need to reflect this shape in that line. Make sure you go point by point, counting down to your reflection line, and then the same distance away. So that's going to go just here. This is going to go here. And then that top one, which obviously means I have to count down through the shape, but square wise, that's 1, 2, 3, 4 away. So 1, 2, 3, 4 goes just here. And there we go. I want to join that up. Read the question carefully, see if it tells me to label that shape with a particular letter, but otherwise, there we go. There is my reflection. It's not asked me to label it, just told me to reflect it, and there we go, it's done. Question 18 is looking at which is better value for money. Now this one does have an added layer of complexity in it because we do have some offers going on alongside it. So it says which offer gives the best value for money, and you must show how you get your answer. So for this one, we have milk sold in 2 pints, and that's 75p, but it says pay for 2 bottles, get 1 bottle free. So if we pay for 2 bottles, that would cost us £1.50, 2 lots of 75p. But we get 1 bottle free. So instead of the 2 pints, if we get 2 that we've paid for and 1 for free, then we get 6 pints. So we get £1.50 and we get 6 pints of milk. So that's the first offer. The second one, pay for one bottle, get one bottle half price. Well, if we pay for one and get one bottle half price, we're not getting 4 pints, we're going to get 8 pints. We just need to work out what we're going to pay for those 8 pints. So £1.28, the half price version, if we divide this by 2, 1.28 divided by 2 is equal to 0.64. And if we add that back to the £1.28, that's going to cost us in total £1.92. There we go. Now write that working out down. We've got £1.28 plus 0.64. So these are the two offers that we have, and these are the two offers that we're going to now work out which is better value for money. So for the first one, on the left here, we are going to do £1.50 and divide that by 6. And this isn't the only way of doing it. You could work out the lowest common multiple of 6 and 8 and then multiply up to that number. But I'm just going to divide by 6 as I'm using a calculator. So £1.50 divided by 6, and that is 25p. So that's, if I write it in pounds, 0.25, or you could write 25p, but that is the deal on the left there. The deal on the right, this 4-pint bottle, we have £1.92, and we're going to divide that by 8. So 1.92 divided by 8, and that gives us 0.24 or 24 pence, however you choose to write it. You can convert the pound numbers here into pennies if you would prefer, and then it's easier to give your answer in pence, but these are quite nice ones to convert. So here we have the 24 pence on the right, which is the better value per pint. So if we need to give an answer here, the sort of answer we want to give is the deal or the offer which is better value for money. So we want the 4 pints is better value for money, or the 4-pint offer is better value, and that's backed up by our working. We can't just guess the answer, we do have to make sure our working is really nice and clear there, so do make sure that you show all those divisions and bits along the way. So there we go, that was quite an interesting one there where we had an offer involved and finding which is the better value. Okay, question 19, we have an inequality on a number line. This is a joint inequality, so it's not just one where we have a circle and an arrow pointed where we say things like x is just bigger than 1. This one here has a joint inequality. So for this one, we're going to write the two numbers that the circles are above, so -3 and 1, and we're going to put a joint inequality in between, arrows always pointing to the left, and if the circle is coloured in, like this one here on the left, then our inequality symbol has the extra ink underneath it, meaning it can be equal to that as well. So there we go, there's our inequality. X is between -3 and 1. Now one thing that we should look out for, which I've not done just now, is what letter is given on the number line. Now this particular one actually has the letter P on it. So really we should put that letter P. However, normally it is okay to put another letter in the middle there, but we should really use the letter which is on the inequality line. So there we go. P is between -3 and 1, including -3. And there we go, there is inequalities on a number line. Question 20 here, we have James is making bird feed mixture for a wildlife centre. He mixes seeds, nuts and fruits, so that seeds to nuts to fruits is 9 to 2 to 1. And he needs to make 6,000 grams of bird feed. Nuts cost £2.25 for 175 grams. Work out the cost of the nuts needed to make the 6,000 grams of birdseed. So we want to know how many grams of nuts he actually needs, and then we can work out the cost of that. Now here, the ratio, the total of that ratio adds up to 12. So we want to share the 6,000 grams into 12 parts, and then we can split it up into the seeds, the nuts, and the fruit, which is 9 to 2 to 1. So 6,000 divided by 12 is equal to 500. So we can multiply all of these by 500. That gives us 4,500, 1,000, and 500. So the one that we are concerned about is the fact we need 1,000 grams of the nuts. Now the question here says nuts cost £2.25 for 175 grams. Now it doesn't specifically say you can only buy the 175 grams, but we will assume that this means that this is £2.25 for like a 175 gram bag. So how many of these bits would we need? Well, 1,000 divided by 175. Now if we type that into our calculator, that comes out as 5.714285. Well, if we're trying to make this mixture, then we're going to need to buy at least 6 bags. We'll have a few left over, but that's fine. We're going to buy 6 bags or 6 lots of the nuts. 6 lots of the nuts, and it says that they cost £2.25 per bag. So here we would do 6 times the £2.25, and 6 times £2.25 is equal to £13.50. And there we go, £13.50. So there we go, there's our final answer, £13.50. Now, to be fair, because it doesn't specify that it can only be bought in 175 grams, it wouldn't be unreasonable to take this number and times that by £2.25. Only because the language here doesn't fully specify whether you can only buy them in 175 gram bags. So it wouldn't be unreasonable if you did that, but there we go, 2 different variations of how you could answer that question. Okay, question 21 is using a calculator. So this one here, of course, you just need to make sure that looks exactly the same on the paper as it does on your calculator. So when you have a fraction involved like this, you want to press that fraction button first, then you can make sure that you double check what's on the top, then you can move to the bottom of your fraction and double check what's on the bottom. Always go back to your calculator screen, double check it before pressing equals. Don't rush because you don't want to miss something, which is very easy to do. And there we go, this one comes out as 1.76527923. And there we go, there is the final answer for that one. But again, that's just making sure it looks exactly the same on the paper as it does on your calculator screen. Part B here says to work out the value of the reciprocal of 0.625. A reciprocal just essentially means to flip it over. Every number can be written over the number 1. So if you flip that over, it becomes 1 over 0.625. So that's doing the reciprocal. From there, we just want to type that into our calculator, 0.625, because it gives our answer as a nice decimal. It comes out as 1.6. Could also write that as 8 over 5, which it simplifies to as well, but there is the reciprocal of 0.625. We have 1.6. Okay, on to question 22. This one here says the table shows information about the heights of 80 children, meaning that this column here adds up to 80. It says work out an estimate for the mean height of the children. Now, as we are doing an estimate here, it's because we need to use the midpoints of each of these groups. So here, we'll write in all of our midpoints first. If you're not sure on the midpoint, maybe they're harder than these ones. You can add together the 2 numbers and then divide it by 2, and that will always give you the midpoint if you're not sure. We now need to multiply across because we'll find an estimate for the total of each row. We have 4 children with a height of, we're estimating, 135. So 135 times 4 gives us 540. We have 145 times 11, which is 1,595. 155 times 24, which is 3,720. 165 times 22, which is 3,630. And the final one here, 175 times 19. And that adds up to 3,325. So for the total heights, or the total estimated height of all of these children, we need to add all of those together. Take your time when you type them in because you are typing in quite a lot of numbers here, and it's very easy just to accidentally click an incorrect button as you go. So do double check every number that you type in. We want to get this total absolutely perfect. 1595 plus 540 and that gives me an estimated total of 12,810. So to get the mean, we take the total, or our estimated total here, 12,810, and we're going to divide it by the 80 children. So divide by 80, and that gives me an answer which came out as 160.125. It's absolutely fine for your answer to be a decimal, but just make sure that your answer makes sense. So let's just imagine it's 160. Well, 160 makes sense because that is a number in the table, and it's quite a popular sort of number here, 24 and 22. 24 there is the modal number, or the modal class would be 150 to 160. So it would make sense that our average, or our mean average here, would be around about 160. So our answer makes sense. We're happy with that. Part B asks us to draw a frequency polygon for this. Now, quite nice, because with a frequency polygon, we use the midpoint as well. So these midpoints that we used for the mean, that's where we're also going to plot a frequency polygon. So it's 135 to a frequency of 4, 135, so it's going to be these numbers here in between the categories, so it might be worth going along and just marking out these midpoints if the lines don't have that extra thickness to them. So that's where we're going to plot our points. The first one, we can sort of remember a few of these, so 4, 11, 24. So we have 4, 11, and 24. I think I might have actually just missed the middle of that there, so let's just count that again. There we go, 4, 11, and 24 is just there. Just count that up from 20, 1, 2, 3, 4, yep. And then we have the last two, 22 and 19. So 22 is there. I haven't missed the middle again, it looks like I have. There we go, 22 and 19 is just there. So there we go, with a frequency polygon, we join this up from the first point over to the last point. We do not join up the bottom, so we just keep it as a dot to dot from the left to the right. Do make sure that those points are perfectly in the midpoints, and of course they have the correct height. So read the scale very carefully, because they are pretty much the only things that can go wrong on a frequency polygon. Either you plot the wrong height, you don't plot the midpoints, or you accidentally join up the bottom there, which makes it incorrect. And there we go, there is our frequency polygon. Question 3, we have a Venn diagram. Now it says here, all the numbers that can be used in the Venn diagram are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. In A we have the even numbers, and in B we have the factors of 10. So we want to write down from that main list which of those are even numbers. So we have 2, 4, 6, 8 and 10. And the factors of 10, we have 1 and 2, 5 goes into 10, and 10 also fits into 10 of course. So we want to identify from this list which are in both. So we have a 10 in both, and we have a 2 in both. So they're going to go into our intersection. So 2 and 10. And we're going to cross those off from the main list so that we don't use those twice. We now have 1 and 5 left over in the B list. So that's 1 and 5, which is now gone. And we have 4, 6 and 8, not 2, 6 and 8. I'm going to write 2 over and over again. There we go, 4, 6 and 8. And we're going to get rid of those from the main list. So 4, 6 and 8. And then what do we have left? We have 3 in that list, we'll cross it off. We have 7 in the list, cross that off. And we have 9 in the list, cross that off. Now just double check that we had definitely put 10 numbers into our Venn diagram, which is the amount of numbers we were allowed. So 3 on the outside, 6 there with A, 8 with the middle, and 10 including the ones in B. And there we go, I'm happy with that. We haven't doubled up any numbers, and we have all the numbers that we were given. Now it says in part B here, a number is chosen at random from the universal set. Find the probability this number is in the set A, and then we have this little N symbol, B. Now that one there stands for the intersection. So this particular one is looking at this crossover point here in the intersection. We could also be asked the little U shape, and that refers to everything within the circles. So the left, the middle and the right, just not including the outside. You do also have the little letter with a dash next to it, which means it can't be in that circle at all, but these are your two main ones here with your intersection and your union. So this one's looking at the intersection, so let's have a look which numbers are in the intersection. Well, we have 2 and 10, so there are 2 numbers there out of 10 in total. So we'd give our probability as 2 out of 10. You don't need to simplify it. You can, of course, but you don't need to. Easiest way is just to write that as a fraction. So 2 out of 10 is the probability that it would be in the intersection. Okay, on to question 24. So this question is looking at speed, distance and time. Now this particular question has a mixture of speeds, and it says in the final line, give your answer correct to 1 decimal place, which does give us a hint here that we are going to get decimals within our answer. Now whenever we have mixtures of journeys like this, I always write a two-way table, just to organise all of my information. So here I'm going to have a row for speed, for distance and for time, and straight away I'm going to write down my formula. Whether you use a formula or a formula triangle is completely up to you. If you do use a formula triangle, you just need to make sure that you know where the letters go absolutely perfectly, but speed, distance and time. There is a massive hint for your speed, distance, time formula in speeds anyway. Here you have kilometres, which is a distance, over hours, which is a time. So it's distance divided by time, literally written within the units. We now have 2 journeys in this question. We have our first journey, which is Oxford to Bristol. We have our next journey, which is Bristol. I'll put Bristol BR because we're now going to Bath, which is BA. So there we go, Oxford to Bristol and Bristol to Bath. And then we have the overall journey. Okay, you can label that with whatever you want. This table is just to help you with your working out. So we have the distance from Oxford to Bristol, 56 kilometres, and we then have 61 kilometres from Bristol to Bath. It says Liam's average speed from Oxford to Bristol was 70 kilometres per hour, and Liam took 75 minutes to drive from Bristol to Bath. So I'm going to write 75 mins, specifying there that it's minutes because we obviously are dealing in kilometres per hour here, so we're going to need that in hours. So it says work out Liam's average speed for his total drive from Oxford to Bath, which is this overall speed just here. Now when it comes to speed, distance and time, distances on a journey can be added together. Times will also be added together, but speeds will not. When we are looking at an average speed, if we were to drive 70 miles an hour from Oxford to Bristol here, and then only drive 10 miles an hour from Bristol to Bath, well, that wouldn't mean we have done an average speed of 80. We've actually done a lot less than that because we've driven really slow on that second part of the journey. This is in kilometres per hour, so I need to make sure that we remember it is in kilometres here, but we can start to figure out bits that we are missing. Now the distances can be added together, so we can work out our total distance by doing 56 add 61. So that gives us 117 as our total distance. We can also work out our time from Oxford to Bristol, that bottom left box. To work out time, if we cover up time on our formula triangle, it's distance divided by speed. So if we're doing distance divided by speed, well, in this case, we want to type that into a calculator. So for this box, we will have 56 divided by 70. 56 over 70 gives us an answer of 4/5 or 0.8. So be very careful at this point because the second part of the journey is given to us in minutes. And what we've just worked out is in hours. So they're in different units, so we can't add them together. The total there is not 75.8. We need to convert the 75 minutes into hours. That's dead nice to do. You just divide it by 60. So 75 out of 60. And we can type that in on the calculator. 75 divided by 60 comes out as 1.25. So those times we now can add together, 0.8 and 1.25. That'll give us our total time for the overall journey. So 0.8 plus 1.25, and that comes out as 2.05, and that's in hours. As it's in hours, we can actually now work out that overall speed. We didn't need to work out this box just here. Of course, just because we've drawn an empty box doesn't mean that we actually had to work it out. The actual speed for that second part of the journey doesn't necessarily help us, because to work out the overall speed, we need the overall distance and the overall time. So here, again, using your formula triangle, cover up speed, it's distance divided by time. So our distance, 117, and our time, 2.05. And we can type that in on the calculator. We know it's going to give us a decimal, and it does. It comes out as 57.07317 with a dot above the 0 and the 7. Of course, it did say give our answer to one decimal place, so that would round to 57 point, and then it's 07, so 57.1, and then double check the question. It was in kilometres per hour, so 57.1 kilometres per hour. So you can see there, that is basically just moving around the two-way table using the formula, and we can add distances and times. So there we go, knowing the formula really well, and just knowing we're just going to have to do a multiplication or a division, depending on which box is missing there. But there we go, our final answer, 57.1. We already have the units on the line, so 57.1 is our final answer. Okay, on to question 25. This one here says there are 48 cows in field X, and the area of field X is 192 metres squared. There are 120 cows in field Y. The area of field Y is a rectangle measuring 15 metres by 18 metres. The area of field per cow in field Y is less than the area of field per cow in field X. How much less? So to start this question, we can have a look at the area per field in field X for each cow. Now to do that, for field X, which we can label here, we have 192 metres squared, 192.0, but that's fine, divided by 48 cows. So 192 divided by 48, and that gives us the answer 4. So each cow in this field has 4 metres squared that they can use. In field Y, we actually have to work out the area of that field. Now the field is in the shape of a rectangle, so it's 15 by 18. So we can work out the area, 15 times 18, which gives us 270. So 15 times 18 is equal to 270, and again that's in metres squared. Now there are 120 cows in that field, so 270 divided by the 120 cows, let's do that on the calculator, and that comes out as 2.25 metres squared. So when looking at the difference in the area here, we have the 4 metres squared, we can subtract the 2.25 metres squared, and 4 take away 2.25 is equal to 1.75. So our final answer is 1.75 metres squared, and that's how much less area the cows have in field Y than they have in field X. So we go, 1.75 is our final answer. For part B here, it says Amir says 40 centimetre cubed is the same as 400 millimetre cubed because there are 10 millimetres in a centimetre. So you multiply by 10. Amir's method is wrong. Explain why. Now, he's not wrong in this bit. There are 10 millimetres in a centimetre. So to get from 1 centimetre to millimetres, or from centimetres to millimetres, we do in fact times by 10. However, to get from centimetres to millimetres, this is correct. But to get from centimetres cubed to millimetres cubed, we in fact times by 10 cubed. So we'd want to write something along those lines. Now 10 cubed is equal to 1,000. So instead of multiplying by 10 in the case of the cubed units, we times by 1,000 or by 10 cubed. So we'd want to write some sort of wording there. Obviously you can use different variations of the language, but something along the lines of, in order to get from centimetre cubed to millimetre cubed, you multiply by 1,000 or you multiply by 10 cubed. Something along those lines, however you choose to phrase it. So there we go, that was some converting between the different area or volume units. The same applies for area. We would instead multiply by 10 squared to to get from centimetre squared to millimetre squared. So there we go, on to question 26. Now for this one we have a compound shape, and it says here the perimeter of the shape is 86 centimetres. Work out the area of the shape. So the perimeter is the distance all the way around the outside. Now we have some of those. We've got 23 going up the top, and we've got 14 going down the side. So this here, this final vertical line, has to be whatever makes 14 become 23. So 23 take away 14, which is equal to 9. We also have some algebraic lengths. So along the top, we have a 6x. We're missing this part here, but along the bottom, it's a total of 8x. So this length would be 2x. 8x take away 6x. So the perimeter we could write as an expression. If we add together the x's, 8 plus 6 plus 2 is 16x. And the numbers added together, 23, 14 and 9, adds up to 46. So there is an expression for the perimeter. But it tells us that the perimeter is equal to 86. So this expression is equal to 86. So we can use that to now actually figure out the value of x. We can do 86, subtract 46, which gives us a total of 40. So 16x is equal to 40. And we can divide that by 16 to find the value of 1x. So divide by 16 and we get x is equal to, and that comes out as 2.5. So now we know the actual value of x, we can actually work out all of these side lengths. Instead of writing them in terms of algebra, we can write them as an actual number. So the 2x length, well, that will be 5, 2 times 2.5, so that's 5 centimetres. 6 times 2.5, and we can just do that on the calculator, comes out as 15. So this one here is 15 centimetres. And the bottom length, therefore, is 20 centimetres. So when you're working out the area of a compound shape, you do want to split this up. This one here is made up of 2 rectangles. So if we split this downwards, you can split it across as well. You could split it into 3 rectangles, but let's try and keep it nice and easy here. So for this rectangle on the right, we have a length of 5 and the height there of 14. So 5 times 14, and 5 times 14 is 70. And the one on the left, we have the height of 23 and the width of 15. So 23 times 15, again on the calculator, and that comes out as 345. And then the overall area we can have as 345 plus the 70, the 2 separate areas. When we add those 2 together, we get an area of 415, and it was in centimetres, so that would be centimetres squared. And there we go, there's our final answer. That does not say 415, obviously I've written my numbers completely backwards there, 415 centimetres squared. And there we go, 415 centimetres squared is our final area of the overall shape. So this does have the units on there, so 415, and there we go, there's our final answer. And that was looking at some forming and solving equations with a compound shape. Okay, so our next question is a reverse percentage. So it says here, Lena's annual salary increased by 6%. After the increase, her annual salary is £42,696.80. Work out Lena's annual salary before the increase. So as it's gone up by 6%, that is now 106% of the original salary that she had. So 106% is equal to £42,696.80. Now we want to get this back to 100%, the original amount, the salary before the increase. Now to do that, we just need to go down to 1%. And again, there are different methods, I'll talk about them both, but this is a really nice way of doing it. We can just divide by 106. And then to get from 1 to 100, we just times by 100. So 42,696.8 divided by 106, and that comes out as 402.8, and then times that by 100, and that gives us £40,280. So that's my final answer there. There is another way that you could approach this. You could approach this again using a multiplier method. Now this number, or the original number, had been multiplied by 1.06. That's how you increase by 6%. So to reverse that, you could also just divide this by the 1.06, reversing that multiplier. That will give you straight, or get you to the answer straight away as well. So either method is fine, whichever you prefer. I just prefer this written method because I can use that for quite a lot of other topics as well with percentages. Okay, so looking at our next question. So for this question, we have some pressure, force and area. It says the diagram shows a solid cylinder on a horizontal floor and the height of the cylinder is 30 centimetres. It says the pressure on the floor due to the cylinder is 1.6 newtons per centimetre squared and the cylinder exerts a force of 75 newtons on the floor. Work out the volume of the cylinder. We're going to give our answer to one decimal place. So in this particular question, we are given the formula, we are given the pressure and we are given the force. So the thing that we're missing from our formula is area. So you can rearrange this formula if you like. You can use a formula triangle. We have the formula given to us. So pressure is equal to force divided by area. And to work out area, it's force divided by pressure. So here we have the force and we have the pressure. So 75 is the force and 1.6 is the pressure. And if we type that in, 75 divided by 1.6, that gives us 46.875. Now that 46.875 is the area, and that is the area of the circular base, as this is a cylinder here, but that is the area of the base. So 46.875, and that would be centimetres squared, as that's an area. To work out the volume of a cylinder or any prism, we get the area of the cross section, and in this case the cross section is the circle that's going all the way through the shape, and we times that by the height or the distance that it passes through the shape. So that distance is 30, so for the volume of this cylinder we would take the area, 46.875, and multiply it by the height of 30. So we can do that on the calculator, times by 30, and that gives us a volume which comes out as 1,406.25. Now we want that to one decimal place, so that'll be 1,406, and the 2 rounds up to a 3. So there we go, there's our final answer, 1,406.3, and that's a volume, and that's in centimetre cubed. So there we go, that is volume of a cylinder, but also dealing with some pressure, force and area. Okay, on to our next question. So this one here is about compound interest. It says Connor invests £200,000 in a savings account for 4 years, and the account pays compound interest at a rate of 1.5% per annum, which just means per year. Calculate the total amount of interest Connor will get at the end of 4 years. So to get the total amount of interest, we're going to first calculate exactly how much he has at the end of 4 years. Then we'll subtract the original 200,000. So with compound interest, this is where you get a new amount each year. Not the same as simple interest, where you only get 1.5% of the original amount. So here, with compound interest, with a calculator, we want to use a multiplier. So if we add 1.5 to 100, 100 plus 1.5, that gives us 101.5%. Now the multiplier for 101.5% you can find in one of two ways. If you type in 101.5 and press your percentage button on your calculator, it will give you that multiplier, which is 1.015. Or you can just divide your percentage by 100 and that'll do it for you. It just jumps the decimal 2 places to the left there when you divide by 100, which is 1.015. So that's what we're going to multiply by. 200,000 multiplied by 1.015. Now we could either do that 4 times. Obviously if we type that in, 200,000 times 1.015, we get 203,000. So you get £3,000 interest in the first year. Now if you were getting simple interest, you'd only ever get £3,000. So it'd be nice and easy if it was simple interest. We'd just do £3,000 times 4 and add it on, or in this case, that would be the interest. But in the case of compound interest, we actually have to put this to a power of the amount of years. So in this case, the power of 4. So you can type that all in one go on your calculator, and we do get a final answer here of £212,272, and to the nearest penny, 71 pence. So that's the amount of money that Connor will have after 4 years. This, of course, tells us to work out the total amount of interest, so we do want to subtract the original £200,000, which I'll write the working out for, but of course I'm just going to type that in on the calculator. Because it's a nice round number, you can actually see the overall amount there, but it's £12,000, 272.71. So £12,272 and 71 pence is the amount of interest that Connor will earn at the end of 4 years. So there we go, that's using a multiplier to the power of 4 in this case because it was 4 years, and that was for compound interest. And then on to our final question, we are looking at using some trigonometry. In this case, we're going to use SOHCAHTOA. So it says to work out the value of x, which is the side length next to that 53 degrees, and it says to give your answer correct to 3 significant figures. Now when using SOHCAHTOA, we want to label the side lengths. So in this case, the longest side, opposite the right angle there, is the hypotenuse. Opposite the angle is called the opposite. However, we don't have the opposite and we're not looking for the opposite, so we don't need to label that. And the final side is the adjacent. Now there are different ways to approach SOHCAHTOA, but here, if we write down our formula triangles, if you use them, the A and the H is in our cos formula. So here we're going to be using cos, and we are going to be looking for the A, which is the adjacent side, and if we cover that up, it's C times H. Now your calculator gives you a big hint, because when you press C, which stands for cos, in your calculator it will open a bracket. Now that bracket opens up to remind you that you need to put the angle in the bracket there. So cos 53, and then we're going to times that by the hypotenuse. Just don't forget to close the bracket. And there we go, cos 53 times 14.5. We can type that in, cos 53 times 14.5, and that comes out as 8.72631. I'm not going to write them all down because it did only want it to 3 significant figures, so we chop it after the 2 there, and that would be 8.7, and the 2 rounds up to a 3. And there we go, there is 3 significant figures, not forgetting with significant figures, that is different to decimal places. The first significant figure is the 8, then the 7, and then the 2. So it's in this case, 3 significant figures is the same as 2 decimal places. But there we go, that is the end of the paper, and that was finishing on some trigonometry. So there we go, hope you enjoyed that paper, and I will see you for our next paper, and obviously, as always, good luck for paper 2.